Welcome to Web Handling. My name is Dave Roysum. I am super excited to begin a new mini-series I call Material Matters. In each of the several clips to follow, we will cover a single commercially important material property. We will outline why this material property is important for product process development, runnability, web quality, web handling, winding, and finally, end-use customer satisfaction. In short, how to use it. Then we will outline how to test that material property and where to find more information about it. I know your time is precious, so let's get started. Look around you. The room that you are now in may have 10, 20, or even 100 different web materials. Paper is the oldest web material. Though it is more than 2,000 years old as a sheeted material, it was about 200 years ago that paper was first made as a web. Paper is also the largest of the web industries in terms of tons and one of the larger in terms of dollars. As the oldest and the largest industry, we should not be surprised to find that paper has many resources and has pioneered much. Many of our lab tests, such as for strength and for thickness, just two examples, originated in paper and were codified by paper organizations such as TAPI, and then replicated by other non-paper organizations such as ASTM and ISO. Many of our mechanical components, such as the ubiquitous roller or the speed control motor, were first tried and first tested in the paper industry. Many online measurements, such as for web tension and for web thickness and for optical detection of defects, originated in paper. No matter what material you make, your heritage is the paper industry more than any other. That is not to say that other industries have also not contributed. Much of the science of air entrainment, winding, and wrinkling began in the film industry. Foil teaches us that even the tightest of conventional roller tolerances may not be good enough for thin materials that are also stiff. Nonwovens and textiles teaches us that one size does not fit all tolerances. These and more flexible materials can tolerate much more before quality suffers. In short, every material has something to teach. There are uncountable products that are at some point made as webs. It may surprise some of you that fiberglass batting is made on almost exactly the same type of machine as paper is. It may surprise some of you to know that cigarette tobacco is made on something like a paper machine. Perhaps most surprising is that a wide range of food products, such as pasta or potato chips, is made as a web roughly resembling how rubber sheet is made. What we learn when we look at this diverse set of products and industries is that testing is important to each and every one. While each industry has its own concerns, certain web properties show up over and over again. Things like strength and thickness are almost universally appreciated, even if the tests for each vary a little bit. In short, every industry has something to teach. I have done troubleshooting in about 1,000 plants around the world. One of the most common observations offered by people I work with is it depends on the material. So what exactly depends on the material? Many things about the web product depends on the material, such as how it is manufactured. Machine design, process design, and process setting all depend on the product being made. Same with converting. Design and settings of the machine it is converted on. More important still is end-use customer satisfaction. That obviously depends on the material. And all of this affects economics, the most important of the items on the it depends list. Web handlers are also intensely interested in certain material properties. They inform us about which defects are most likely, and perhaps even how likely they will be. They inform us on how to design the mechanicals and controls and maintenance for our machines. They inform us on what settings to run on our machines. They inform us about runnability and windability. Yet, despite the wide variety of materials, material test methods, and material test values, there are some things that do not depend on the material. Perhaps the most important is that the laws of physics for web handling and web winding do not depend on the material. It then follows that behavior or misbehavior also does not depend on material per se. Thus, no matter whether your wound roll telescope is on paper or film or a paper film laminate, you would begin troubleshooting the same way. Specifically, determine which subcase of telescoping you have, because there are about a dozen defects here, all distinctly different, that share approximately the same look. How to troubleshoot telescopes and other wound roll defects is covered in great detail in my award-winning and trademark Web 101 class that has been taken by 5,000 students. Thus, no matter whether your wrinkle is on paper or film or a paper film laminate, you would begin troubleshooting the same way, specifically to determine which subcase of wrinkling you have, because there are about 24 wrinkling defects, all distinctly different, that share approximately the same look. How to troubleshoot and web defects such as wrinkling is again covered in great detail in my award-winning and trademark Web 101 class. Once we learn web handling, we would then know it is not the material that matters, rather it is the material properties that matter. For example, because plastic film and coated paper both have similar moduli and strength, we would know that drive control strategies and tension settings would be similar. Because film and coated paper are smooth, we can expect that we might need to groove rollers and wind with a nip at higher speeds as a consequence, irregardless of whether the material is paper or film. Once we learn web handling, we would know that it is not material that matters. Rather, it is material properties that matter. For example, nonwovens and tissue are both rough, and most are low modulus materials. Thus, we would know that drive control strategies and draw settings will be similar. We can also expect that dimensional stability, such as for meeting length, width, and thickness, will be challenging for both nonwovens and tissue and other materials that have similar material properties, regardless of their chemistry. So, how many different web tests might there be? Well, if you work in a small plant, you may only test perhaps 10 different properties. Larger corporations may have 100 tests that are routinely done in their many test labs on the wide variety of products that they make. Some testing facilities, most notably Forest Products Innovation outside of Montreal, can do more than 1,000 different tests. Yet, if we look worldwide across the wide and diverse set of web products, the number of tests will be much, much larger. Obviously, we will not be detailing anywhere near that many tests in this mini-series. In this short mini-series, we will focus on only a dozen of the most important web tests. Every item on this list is very significant in predicting web behavior and web misbehavior. Most on this list are common lab tests and are central to common commercial specifications. My guess is that most of you test or should test many of the properties on this list. Some industries, such as paper, likely measure them all. There are two starting points to learn more about material behavior and testing after you finish this mini-series. The first is the 750-page must-have Web Handling Handbook. We have an entire chapter on material properties and many pages of test standards in Appendix T that would be helpful for quality control, troubleshooting, and web handling work. The next is my award-winning and trademarked Web 101 class that has been taken by 5,000 students just like you. Here, you will learn which material properties are needed for web handling work and why they are predictive. Thank you so very much for joining me in this Material Matters series. Stay tuned for the next clip where we will meet a most important property, weight. If you have a test property that you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.